plugin for Burp that decodes. It uses the same logic that Richard Berg used, basically just ported his logic over and converted it to Burp. And the way the Burp interface works is there's two methods that it uses. One's called the process proxy message, and one's called process HTTP message. And simply, one of them will hook into the message before you intercept it. The other one's going to hook into the message after you intercept it. So what it's going to allow us to do here is, I've got it running, and I'll show you that same exact message going through the Burp proxy interface. I've just got a second instance of Burp running on port 8081. And what's going to happen here is, let me just make sure the intercept is turned on. And if I go ahead and submit another message, say 23 plus 3, and we go down to this Burp interface, you can see here that now I'm actually looking at readable XML. So this becomes really easy for me to then go ahead and manipulate. So I'll change this to 53 plus 3 and forward it on. Now the interesting thing is that you'll notice here when the response comes back, it's still binary. And I'll talk about that in a second. But at a minimum, for editing the request, this works pretty well. So that's a free plugin. You can download it off the GDS security website. Now, the one thing you'll notice there that I pointed out is that the response data is still encoded. And the reason for that is that the two methods in the Burp interface that we're hooking into, process proxy message and process HTTP message, both actually get hit on the response side before you can edit the data. So there is no method to hook into, and this is something that I contacted Portswigger about, who's the guy that wrote Burp, just to confirm that there was nothing I was missing here. And there really is no method you can hook into to transform the response data after you intercept it. So there is a workaround for this, which is a little clunky. It's not very elegant, but it works. And that is, you can just chain two of the proxies together, and then you set the first one to decode and edit the requests, and then the second one to decode and edit the responses. So you have one instance doing your requests, one instance doing the responses. And then the way that each of those ends up talking to each other is they set the plugin actually sets a custom header that notifies the next proxy in the chain that the message either needs to be encoded or decoded. So if you do need to edit response data, it's not a very common scenario. This is really just if you want to try and trick the Silverlight client into doing something and thinking that the web service gave it something it shouldn't have. You can certainly use this workaround, and it'll get you there. So at this point, even if we're looking at a Silverlight application, we still need to get metadata, or we're still going to want to get metadata about the web service. And the reason for that is that if we're only looking at the Silverlight client and we're only exercising the Silverlight client in the browser, we may be limited as to the calls that the Silverlight client is making. There could be a bunch of other good stuff back there that we want to get to. So just like in the legacy ASMX web services, there is a way to pull metadata, the WSDL, the WSDL, through a GET request. And that's the same way you used to do it. It's basically append the question mark WSDL to the end of the address, and if that feature's turned on, it'll return the WSDL. The drawback here is that that is not turned on by default in WCF. As a matter of fact, none of this stuff is turned on by default. There is no metadata that comes back unless the developer turns it on. So that's another example of this sort of opt-in approach that Microsoft's taken, where historically the WSDL was published all the time unless you turned it off. That's not the case anymore. There's also a second mechanism of getting metadata from the web service, and that's basically using what's called the MEX binding. And MEX is basically short for metadata exchange. It's actually an open standard. There's a W3C draft on it, and it's a specific message standard for obtaining metadata from a web service. And the way a MEX request works, this is just an example. If the helper page, if you remember back in the legacy services, they always had this helper page that would get displayed. It used to show you the different post requests that you could make to talk to the web service. It doesn't do that anymore. It just basically shows you how to generate an interface to the web service if you needed to. The other thing that you'll notice there, and we'll talk a little bit more about this later, is you'll see that there's a cryptic host name there, even though that doesn't map up to the host name that's in the URL. And the reason for that is by default, the web service is going to return its host name within the metadata. There's an option you can turn on to change that and make it a fully qualified domain name. But if you're trying to obtain this metadata and you're having problems resolving a host name, it's probably because the web service is returning its internal host name and not the fully qualified domain name. So The good news is that while all of this stuff is turned off by default, if you use Visual Studio to generate your web service, which 99% of people out there do, it's going to generate an automatic template for you when you go to create a new web service. And by default, in that template, it's turned on the metadata, the WSDL through the query string, as well as defines an endpoint for MEX with a address of MEX, as you can see up here. So the good news is that even though it's off by default, I'd say a good 80% of the time you're going to end up having access to the metadata anyways. And the way you would obtain this, if you want to issue a MEX request to the web service, is it's a post to the address of the service along with whatever address was defined for the MEX endpoint. So again, if they're using the default Visual Studio settings, it's just going to be /MEX. And then you have a very simple body here that basically just includes the address that you're actually issuing the MEX request to, and it'll then return the data. So I'll show you an example of what that looks like here. In our Silverlight service, we've actually got the metadata turned off for, just pull it up here. Metadata is actually turned off for this web service. So if I look at the history, I can see I'm actually going to Silverlight Calculator service.svc. I'm just going to go ahead and turn off Burp for now since we don't need it. You'll see that if I issue a GET request, it actually returns a 404. So it's actually kind of tricky in the sense that you might actually be fooled into thinking that the web service isn't even there. The thing is that it is there, but if metadata is turned off and specifically the GET method is turned off, which is what we've done here, it's just going to return a 404. So the way to get metadata out of this endpoint is going to be to issue a MEX request. And I'll show you real quick what that looks like. I've got one in Burp repeater all set up here. So we're just going to issue a request, as I said before, to the address along with /MEX, and the body is identical to that message that we saw on the slide. And what you'll see there is it basically returns all the WSDL information. It just returns it in a SOAP envelope instead. So it's basically the same information you used to get. It's just a different way of getting it. Now, this still might not be enabled if they've gone through a security review and somebody pointed out, hey, you shouldn't be publishing your metadata. You may not be able to do this. One thing to keep in mind is that while it is turned on by default in the Visual Studio template, with WCF you actually have to specify whether you want metadata to be published over HTTP or HTTPS. So if you're accessing a web service over HTTPS, even if they've got the metadata turned on, which is by default in Visual Studio, it's the top one there, which is only over HTTP, it will not serve MEX requests or WSDL requests over HTTPS. So that's another thing that may have you sort of banging your head against the wall is, why can't I get this metadata? It is specific to HTTP or HTTPS, so certainly try both if you have access to both. The other thing now is that there's, as we've seen here with Burp, and with Fiddler, there's not many tools out there that support, a lot of the standard web service testing tools out there don't support the different types of protocol bindings that WCF uses. So there's a couple that you can use there that are free and easy to get to. The first one is the default WCF test client that comes with Visual Studio. If you don't have Visual Studio installed, there's a guy who posted, he basically just extracted the relevant DLLs and files needed to run this client, and he published in a zip, so you can download it for free and pull it that way. The other one that I like that has a free version is called WCF Storm, and these are both GUIs that make it sort of nice and easy to, I'll show you an example of the Visual Studio one. It basically, you just load up the web service, you point it towards the metadata endpoint, and it'll then generate a GUI that'll allow you to plug in values and show you the response that comes back. And the nice thing about these two tools, the reason I'm using them, is that no matter what the protocol binding is that they're using, for the most part, these will support, these are written in .NET, so that it's basically just like another .NET application talking to that service. And we'll see a little bit, we'll talk a little bit more about those utilities in a second. The other option you have is, okay, let's say we have no metadata that's being published at all. They've locked the thing down. Well, if this is a Silverlight application, the nice thing we can do is if it's consuming a WCF service, chances are all they did was generate a stub to the web service using the Visual Studio service utility, and that stub is going to include all the